Yes, good afternoon. I think there is a question or a clarification required on this detailing. This is also this is a three-cell box culvert. They cut a typical section. They did not cut areas of the section where you have the wing wall, and so they just demonstrated this one. Please note that box culvert wing walls can be integral or what we call monolithic, or detach with a separate footing and you have a joint. That one you need to bear in mind, because tomorrow someone will come up with a box culvert with a disjointed wing wall and you begin to say this is not what we studied. No, it can be separate. Even for abutment for bridges, you can also have a separate wing walls with a separate footing. So you just design your box and that is it. If you look at this this box culvert, it has a cushion, fine, but the top slab is disconnected from the bottom, from the walls and the bottom slab. They have a connecting, you can see reinforcement terminating, and also they have a what we call dowels for connecting it to avoid shearing off or for lateral movement. So it is like a U-type with a drop slab. This slab is just placed with anchoring only. Doesn't take another thing. So when you design it, it's just going to be a continuous member which is pinned on the external walls and the internal walls. One thing also you need to note, if you look at this line here, this is a construction joint. You don't cast concrete at once. You do the foundation first, and then later you do the walling, and then you do the upper part. But in most cases, I think what the contractors do, they do foundation first up to this construction joint, then after which they prepare reinforcement cage for both the walls and the slab. Then they prepare this they prepare the formwork and they cast at once. So that actually the best would have been you prepare your mold and then you cast the whole thing without creating a joint. That is what you would have what they call a continuous or a monolithic construction with a proper rigid connectivity. When we have construction joints, gentlemen and lady, you just know that if you don't do it well, these are what we call weak lines. This is where you will have water leaking into reinforcement if it is not well done. And in your concrete technology, they have explained how you manage horizontal and vertical joints where construction is not done at once. You do today construction, then tomorrow or after a week you come. Recall if flood happen and where you have stopped, it is covered submerged in water for a week or two. Then water subsides. You come and you want now to clean the reinforcement, clean that joint, and then start the reinforcement work for the walls. As an engineer designer, let's leave alone now construction. Now you are a designer who is going to look at your design. Then you have a project manager also coming. The project manager will be crying of what? Delayed time of delivery. While the designer will be crying of what? Oh, my design, will it work? My reinforcement great, my reinforcement quality, now it is covered in dirt and contaminated stuff, chemicals and the rest of it. Shall the concrete have the required bonding? The durability might have been compromised. The cry is about how he labored to design and is looking at the functionality of the bridge. While the project manager will be just saying, no, I have to deliver. I have a set timeline. I must do it. I know project managers have the three constraints to monitor: the quality aspect, the time aspect, and the cost aspect. But what they normally tend to downplay is the quality aspect. Where quality comes, they continue demanding delivery. So this is now where you need to note that if you become a project manager tomorrow, and another one, if Button is the project manager, Tala is the designer, and Alfred is the employer. You will have parallel argument on this kind of construction. I know you're going to pull tensions, but you have to understand. The engineer will always object certain approaches that compromise on functionality. And that is very, very important. So take note of this. Admire the detailing aspect, understand the detailing, look at the curtailment, look at the cover requirement, look at where the lapping is done, what are the lapping requirements. Go and read about this thing. These are exactly the entire reinforced concrete structure you have studied, the theory aspect. The distribution bars, the normal, how distribution bars are laid, what sizes, the main one calculated. Normally you calculate the main one, while then you look at the size. So many things you'll have to look at. Cover, what they call the concrete blinding, and the rest of it. So this is another form. You can also have what they call the prototype, whereby the walls and the top slab are monolithically cast, designed and constructed, and all this one down here are pinned. Then this concrete slab, what they call the base slab or the bottom slab, will be cast first. Then you leave pockets to control shear, and then which is designed also. Then you come and do this thing here, the top slab. So basically that is what I could say. I have seen Lawrence has already shared with you the detailing of wing wall, main wall connection. One thing you need to know is there is I misplaced a very good theory about how to design a wing wall. Wing walls joins are subject to tension, moment, and shear. Those three forces must be calculated, must be designed for, and that is how you determine those reinforcements. Those reinforcements are not just placed anyhow. It is derived from calculation. So as the upcoming top-notch engineers, don't just go and pick anything. There is a theory behind it. If I get that one, I will share definitely, and then you have to appreciate, keep it, write it, and make it part of your assessment. As engineers, don't go and become rumor mongers that I saw it happening elsewhere. No, take time, sit down, do a model, calculate, get what are the issues, optimize design. So when you go and they say, no, this bars can't work, no, the other one can work, that one is gambling. Make sure you know the range. That is 16 at 200 is an equivalent of 12 at 125, an equivalent of 10 at 75, and an equivalent of T20s at 250. But the wider the bars, the more it is subjected to crack. Cracks also have limits. So take note of those things and become a good engineer in practice. Thank you. I hope this clarifies. Bye.